Lesson 17 is called performing operations on functions, and in math, operations means like addition or subtraction, multiplication or division. So in 17.1, we're going to focus on adding and subtracting functions, and we're going to start off with adding functions with more of a real life example. So up at the top, imagine car A is 20 miles east of a gas station and car B is 15 miles west of the gas station. Car A goes east, traveling 50 miles per hour, and car B goes west, traveling 65 miles per hour. If the cars will not change their directions and will keep their speeds, how far apart will they be after any given number of hours? So I'm going to ignore the functions for now. We'll go back to those. I just kind of want to visualize what's happening here. So if we have I'm going to draw a little compass up here. So north, east, south, and west. So going east, if we're just kind of looking at the compass, is going to the right, and then going west is the exact opposite direction. It's going to the left. So it says car A is east of the gas station, and it's also heading east. So we can picture it as car A is going to the right, car B is west of the gas station, and it's also driving west. So these two cars are starting off a certain distance from the gas station in each direction, and they're also driving apart from each other. So their distances are going to be growing. And then we can kind of represent their distances in function form. That's what's given down here. So a of x is the function that represents the car A's distance away from the gas station. So car A is starting off 20 miles east of the gas station. That's where this 20 comes from, is the starting value for car A. And it's also traveling east at 50 miles per hour. So that's why we have 50 times x right here, because our rate of change is 50. And then for car B, it's b of x equals 65x, because it is starting off 15 miles west of the gas station, so just on the other side of the gas station, and it's traveling west at 65 miles per hour. So each of these functions represents each individual car's distance away from the gas station. Car A is to the east, and then car B is to the west. So now each of these cars are traveling further and further away from each other, and we want to find not their distance from the gas station, we want to find how far apart they'll be from each other. So that last little line in the problem says how far apart will they be after any given number of hours, so how far away are car A and car B. So we need to find the distance they are in total, which means combining the two distances from the gas station, because the gas station is somewhere in the middle. So if we want to find their total distance, we need to add each of their distances from the gas station. So we're going to add the two functions. So we'll say our total distance is going to be a of x plus b of x. And adding functions is no different than adding everything else in math. So we just get to add them and combine like terms. So a of x, I'm going to put that right here. It's 50x plus 20. And then I'm going to add that to b of x right after it, which is 65x plus 15. So plus 65x plus 15. And then now I have a function that combines their distances, and I just need to simplify it, because if we ever can simplify it, we should. And so that means checking for like terms. So I have, remember, like terms have the same variable with the same exponent or just no variable whatsoever. So I have a like term right here and right here in the 50 and the 65x. So I would add those two together by just adding what's called the coefficients. Those are the numbers in front. So I would do like 50 plus 65, which is 115x. And then any numbers that don't have a variable, they're called constants. Those would also be like terms with each other. So the 20 and the 15 would be like terms. So we would add those two together. So 20 plus 15 would end up being 35. So plus 35. And then we originally wrote like kind of the sum of our two functions as a of x plus b of x, like two separate ones. But there is like a more condensed way of writing it, slightly more condensed. And that would be to kind of combine them all into one function notation. And that would look like this: a plus b of x. So these two kind of parts of the problem, they mean the same exact thing. They're just two different notations. So a of x plus b of x means you're adding the two functions together. So does, this is read as a plus b of x. And that just means the two functions added together. So in the end, the distance that the two cars are apart from each other are 115x plus 35, or a plus b of x equals 115x plus 35. Okay, so moving down to the section that says function notation, this is just kind of like comparing what I just spoke about with the a plus b of x. Most of the time you'll see f and g's, but we just kind of want to recognize that these kind of mean the same thing as each other. So under addition, f plus g of x, that's the first one, means the same thing as just adding f of x plus g of x, just like we did in the last problem. And then for subtraction, if we have f minus g of x, that just means f of x minus g of x. For subtraction, you will have to be more careful with order. Like if they switch the order on you, you need to be more careful. Like if you were finding, say, g of x minus f of x, you would need to be careful about which function you write first in your problem. Okay, so subtracting functions now. So in this problem, f of x is 3x squared minus 7x plus 13, and g of x is 5x squared minus 18. And we want to find f minus g of x. So that just means that we're going to take f of x and we're going to subtract g of x, and we're going to keep it in the same order as it's given in the problem. You could see it the other way around in the future where it says g of x or g minus f, and you would need to switch the order there as well. But this is f minus g of x, so that's what we're going to do. So I'm just going to drag this over really quick actually so I can set it up as my kind of reference. So f of x is going to go first. And f of x is 3x squared minus 7x plus 13. So that's going to go there. So 3x squared minus 7x plus 13. And then from there, we're subtracting g of x. And we didn't have to do this when we were adding, but when you're subtracting, you need to put the function that you're subtracting in parentheses if it involves more than one term, which g of x, this has 2 terms, so it will need to go in parentheses to make sure that I subtract the entire function. So it'll be minus 5x squared minus 18. And whenever you're subtracting functions or like expressions, there's always that added layer of needing to distribute the negative that you don't have to do when you're adding them. So what that means is I'm just going to bring down f of x. So all of this that's not in parentheses that came first, that's just going to come down as is. So it'll be 3x squared minus 7x plus 13. And then now everything that I'm subtracting, I'm going to have to distribute that negative. So what that means is that this is like a -1 in front of here. And I'm just going to distribute that negative to everything inside of the parentheses. And what that does is it changes the signs. So if I did -1 times 5x squared, that would become negative 5x squared. And then -1 times negative 18 would become a positive 18. So it keeps the numbers the same, it just changes the sign, changes positives to negatives or negatives to positives. And now that I've done that, I can take off the parentheses and it becomes just like an addition problem where I'm combining like terms. So my next step is going to actually give me my final answer. So I'm just going to go ahead and write that other function notation of f minus g of x equals, and then I'm going to go through and identify what my like terms are. So terms that have the same exponent with the same variable. So the ones that have the x, or sorry, I just said it backwards. Same variable with the same exponent. So like I'm looking at the x squareds right now because they both have x to the second power. So those are like terms, I can combine those. by just adding the numbers in front. So I would do like 3 plus negative 5 or 3 minus 5. That would be negative 2x squared. So I'm done with the ones I have in pink. And then for my like x to the first power, I only have this one, like x to the first power, so I don't have anything to combine it with. I would just bring it down next. So I'd bring down my negative 7x without making any changes. And then now I have my constant terms. Those are the ones that don't have a variable. So 13 plus 18, I can add those two together. 13 plus 18 would be 31. So I would bring down a plus 31. So altogether I have f minus g of x equals negative 2x squared minus 7x plus 31. Okay, moving down to 17.2, this is one where we're multiplying functions. So we have a new little function notation to go over. So where it says multiplication, if you have f times g of x, that is the same thing as f times, or I said it, yeah, I kind of said it backwards. Okay, anyways, if you have f of x times g of x, that's the same thing as f times g of x. So just, they mean the same thing, but it's important to just recognize that they are the same in case you see one way written or the other, regardless of if the multiplication happens like kind of in between the two separate functions or the two functions are combined together in here. It just means that you're taking the two and multiplying them. Okay, so example 1, f of x is 2x squared plus 3x minus 1, and g of x equals 4x plus 10, and we're supposed to find g times f of x. So what that means is we're going to do g of x times f of x. And when you're multiplying, technically order doesn't matter, but I'm going to keep mine in the same order as this is. So g of x times f of x. So g of x is 4x plus 10. So 4x plus 10. And when you're multiplying, kind of the same thing as when you're subtracting. If you have more than one term, it needs to go in parentheses. So like this is 2 terms. Terms are separated by a plus and minus. So g of x has multiple terms. I'll put those in parentheses. That's this section right here. And then it's going to get multiplied times f of x, which is 2x squared plus 3x minus 1. And that definitely has more than one term because this would be 1, 2, 3 terms even in g of x. So we'll definitely put, in f of x. So we'll put f of x in parentheses as well. So it'd be 2x squared plus 3x minus 1 for f of x. And then now that we have this set up, we're going to have to kind of do the distributive method multiple times. So as you get comfortable with these, you don't have to do it in as many steps as I'm going to show you here. I'll show you kind of maybe the step that you'll get to skip later. But for this example, I want to show as many or as much detail as we possibly can. So what we're going to do is we're going to take each term in the first parentheses and distribute it to the second parentheses. So we're going to do 4x times everything in that second parentheses. So it's going to be like 4x out in front. And then the second parentheses, I'm just going to copy that down. So 2x squared plus 3x minus 1. So I took that 4x and I distributed, too many D's, by everything in that second parentheses. And then now I'm going to do the same thing with that 10, the second term in the first parentheses. So since that was a plus 10, I'll do plus 10. And it multiplies by everything in that second parentheses. So 2x squared plus 3x, and then minus 1. And then now that I've shown that each term in the first parentheses, the 4x and the 10x are going to get multiplied by that second parentheses, I'll just go ahead and distribute them again. So I'm going to give myself a little bit more room here because I got a little cramped. And now I'll go ahead and distribute everything, the 4x by everything in the first parentheses. So it'll be 4x times 2x squared. So you do 4 times 2 is 8. And then x times x squared would go up to x to the third power, because remember, when you multiply powers, you add the exponents, and that's like an x to the first power. So 1 plus 2 would be 3. And then I would take 4x and I would multiply it by 3x. So 4 times 3 would be 12. And then x times x would become x squared, because this is like an x to the first power, and 1 plus 1 would give me x squared. And then next I would do 4x times -1, which anything times 1 just stays the same, but since we're multiplying this by a -1, it'll become a -4x. So then we're done with the first kind of set of parentheses up there. So that's everything from distributing the 4x. And then now I just need to pretty much do the same thing with the 10. So I would do like 10 times 2x squared. Since the 10 doesn't have an x, none of the x's are going to change. So 10 times 2 would be 20, and then x squared, that would stay the same. And then 10 times 3x, 10 times 3 would be 30, and the x stays the same, so 30x. And then 10 times -1 would be -10. And then now we've distributed the 10 to all three terms. And now we just need to go through and combine like terms, and that's going to be our last step. So I'm going to write out my final function notation. So it'd be g times f of x equals, and then I'm going to go through and identify which terms have the same variable with the same exponent. So the like 8x to the third power, you always start with like the highest exponent first, but that's my only x to the third power. So I'm just going to copy that down because I don't have anything to combine it with. And then next I have 12x squared and 20x squared. So I would add the coefficients to the number in front. So 12 plus 20 would be 32. And the x squared part stays the same. And then next I have -4x and 30x. So -4 plus 30 is the same thing as 30 minus 4. So that would be the same thing as 26x. And then last, I just have that 10 that's, or -10 that's at the end, and that's my only constant term, the one that doesn't have a variable. So I would just bring it down. It wouldn't be able to combine with anything. So altogether, I have g times f of x equals 8x to the third power, or 8x cubed, plus 32x squared plus 26 minus 10. Sorry, plus 26x. I don't think I said that. I'm going to say it one more time. So g times f of x equals 8x to the third power times 32x squared plus 26x minus 10. Okay, so sorry, I forgot to put any spacing between the last two problems, so I had to jump up and like add the spacing in so we could get those done. This is the last section at 17.3, and it's combining functions from context. So just taking more real life examples. So example 1. The length of a rectangle is 5 less than 3 times its width. Write a function to represent the area of the rectangle. So I'm going to draw a picture. We have a rectangle. It says that the length is 5 less than 3 times the width. So since everything is like in terms of the width will just be its own variable. So we'll put the width as just w. And then we want to write the length in terms of w, or in terms of the width. So because it says 5 less than 3 times the width, that would be 3 times the width, so 3w, and then minus 5. So 5 less than 3 times the width, I'm going to extend that out so it includes the width. 5 less than 3 times the width is 3 times the width minus 5. So this will be 3w minus 5. And then we want to write a function that represents the area of the rectangle. So I'm going to call it a of x for area. And then the formula for the area of a rectangle is length times width. So our length is 3w minus 5. So we'll put that in for L. And then our width is just w. So we'll put w in for the width. I mean, it's already there, but we'll just kind of keep it the same. So the length is going to be 3w minus 5. And since there's multiple terms there, we're going to put it in parentheses. So 3w minus 5, and then times the width, which is just times w. So it'll be 3w minus 5 times w. And then now we want to simplify, so we're going to have to distribute. And it's actually okay to have the w behind. If you want to bring it around to the front, if that makes it make more sense, you can distribute it in. But we can also just keep it behind and distribute it backwards. That's totally fine. So it'll be a of x equals, I'm going to distribute it backwards, so it'd be w times 3w, and that would become 3w squared from the w times w. And then we do w times negative 5, that would become negative 5w. So minus or negative 5w. So altogether, our function that represents the area is going to be a of x equals 3w squared minus 5w. Okay, so example 2, Jim throws a ball in the air when standing on the bleachers at 15 feet above the ground. The height in feet can be modeled by the function j of t equals negative 16t squared plus 25t plus 15, where t is the time in seconds. Mike is standing on the ground and he also throws a ball in the air, but he's a little bit stronger and his throw goes higher. The height of the ball Mike throws can be modeled by the function m of t equals negative 16t squared plus 30t. Write a function that shows how much higher Mike's ball will go. So that means that we're trying to find, like, so if we picture like Mike, he throws the ball, or we'll start with Jim because it's Gabe Jim's first. So Jim throws the ball and it goes this high. And then Mike is like a little bit stronger, and so he throws the ball and it goes a little bit higher. And if we're trying to find how much higher Mike's ball is going to go, then we need to find the difference between their two throws, and the difference means we need to subtract them. So it doesn't specifically say like the word difference in this problem, but you will see that a lot in the future. So I'm going to add a note here that we want to find the difference between the two throws, and difference means subtraction. So that's an important word to know, especially when we're doing word problems. So find the difference between the throws, and then add a note that difference means subtraction. Okay, so since Mike's throw is going to go higher because he was the stronger one, we want to take the throw that goes higher and subtract the one that's lower. We like when you subtract, you'd want to do like the bigger number minus the smaller number. So we want to take the higher throw, which is Mike, and subtract the lower throw, which is Jim. So we're going to do Mike's throw, which is m of t, and we're going to subtract Jim's throw, which was j of t. And one more time, we're doing it that way because Mike's throw went higher. So we're doing the higher throw minus the lower throw. So Mike's throw is going to go right here, and that was negative 16t squared plus 30. So negative 16t squared plus 30t. I think I forgot to say t the first time. And then we're going to subtract Jim's throw next. So we'll do minus, and then since Jim's throw has multiple terms, we're going to put it in parentheses. So minus parentheses negative 16t squared plus 25t, and then plus 15. And then it'll be the same as the other subtraction problem where we're going to have to distribute that negative to the second parentheses. But first, everything in the first like kind of blue section of the problem before the minus, before the parentheses, that's just going to come down. So we'll bring down negative 16t squared plus 30t. And then remember, this is like having a negative 1 out in front. So what we're going to do is we're going to distribute that negative 1 to everything in that parentheses, and it's going to flip all the signs. So negative 1 times negative 16t squared would become a positive 16t squared. Negative 1 times a positive 25t would become negative 25t. And then negative 1 times 15, a positive 15, is going to become a negative 15. So all the numbers are staying the same, but they're switching the signs. And then now that we've done that, we're able to just go ahead and start to collect the like terms and see what's in common and what we can combine. So once we combine them, that's going to end up being our final answer. So I'm just going to combine our function notation into m plus j. Nope, not m plus. I don't know why I said that. M minus j, because we're subtracting the two. So m minus j of t equals, and then we'll go through and identify like terms. So we'll start with the t squareds. So I have a negative 16t squared and a positive 16t squared. So if you have two of the same numbers, but one is positive and one is negative, when you add them together, they're going to cancel out. It's going to be 0. So I'm just left with 0t squared, but I don't need to write that. I can just cross them off because they cancel each other out. And then I have a 30t and a negative 25t. So that's like 30 minus 25, which is 5t. And then at the end, I just have that minus 15. It has no other like terms with it, so I would just bring it down. So minus 15 right here. And then our final answer is simplified, so this is where we get to stop. So we would say m minus j of t, that's Mike's height minus Jim's height on their throw, is equal to 5t minus 15.